My channel Maths with Armin. This is another video on probability that I've prepared. It's on specifically on how to use Venn diagrams to determine probabilities. We're going to look at Venn diagrams with 2 events, and we're going to look at Venn diagrams with 3 events. If you have not yet subscribed to my channel Maths with Armin, please don't forget to subscribe. Now let's start. I'm first going to explain to you the concept of Venn diagrams, and then we're going to show you how you can use Venn diagrams to do probabilities. We'll first take a basic one where we have 2 events, and then we'll take one with 3 events. And then as usual at the end there'll be an exercise worksheet with solution. The concept of Venn diagrams. To explain what a Venn diagram is, I'm going to look at use an example. We're going to take one where we have 2 events first. So let's take an example. We have a class of 30 learners who have a choice between mathematics and accounting. 20 of the learners indicated they take mathematics, while 15 learners indicated they take accounting. Okay, so let's see that we're going to represent our sample space, we refer to as S, using a rectangle. So normally when we draw a Venn diagram, we're always going to use the sample space is going to be a Venn diagram. And let's see what information is given. We have event A taking mathematics, and we're going to represent the events here using circles. So event M, we just label it as M. Then I have another event A, let's label it like that. There's the 2 events M and A. Let's look at what information is given. We've got a sample space size of 30, so there are 30 learners. Now where do we put the 30? We have to put the 30. The 30 represents the whole, so we don't put it inside, rather put it on the rectangle. They don't put it inside. Then the size of event M, there are 20 learners. Also not going to put the 20 inside. Let's put the 20 there by the M. You see that? So that 20 represents all the mathematics learners. The same with the accounting, we have 15. We just put the 15 there. Now if you look at our information, we have 30 and we have 20 and 25. So if I add the 15 and 20, I get a 35. But I only had 30 learners. So in other words, it doesn't equal the sample space. How do we explain this? That's right. There are some of the learners who take both mathematics and accounting. So how many do you think that is? So in other words, there will be an overlap. There are learners who take both mathematics, so we can't have the 2 circles separate. So we need to have the 2 circles overlapping. There they overlap, right? And what is that overlap? 35 minus 30, can you see? There's a 5 that belongs to the maths and also a 5 that belongs to the accounting, as you can see. So we need to remove one of those 5s. Right? That's why we got a 35 there. So there we now have we can just have a 5. But if I look at the mathematics was 20. Therefore, the remainder of the mathematics there would be 20 minus 5. That will give me my 15. Okay. The same there, the counting was 15, and the remainder there would be 10, because you can see 20 plus 5 is 20, 15 plus 5 is 20, and 5 plus 10 is 15. Okay? So there we've represented the 5 there is the overlap, and if we now look at, there's our Venn diagram. You can see there we've got our 30. 15 plus 5 plus 10 represents 30 there. So we represent this here using a rectangle, and we have 2 overlapping circles. Because there's a common portion, I would have it overlap. Now, I want to show you how to understand a Venn diagram. What I mean by that, if you have a Venn diagram, let's look at all the regions that we have in the Venn diagram. Let's take this one here. There I've got a sample space A, B, C, D. So my sample space consists of a B, a C, and a D. X consists of A and B, and Y consists of B and C. You notice anything there already? That's right, there's an overlap of B. In other words, I have an overlap of B. If I can see here, I've got A, B, so X consists of A as well as B. Y consists of B and C. But because my sample space consisted of 4 elements, I now have a D there. So let's look at specific parts there. We want to see each region. There's the A, there's the region B, there's the region C, and there's the region D. Let's try to understand our different regions in our Venn diagram. Let's first of all, if I say only X, right? In other words, I want to know what is only X. If I look at X, X is partly X, and then it's also a part that also belongs to Y. So only X there, there's the only X. Only that piece is the only piece that belongs to X, right? So in other words, only X only consists of A, right? So only X, if I look at that, there's my only X. That's the magenta part that I've highlighted. So only X there I've shaded in my, I've represented. That's what we mean when we say only X. What if we say only Y? Only Y. I look at only Y here. I will see that the only Y would be that. See, there's the only Y. Right? That portion there is only Y. And that is only C. So if you look at that, you can see there. So only X, you can see that's what only X is. And there I have only Y. Right? So I've taken out the portion of X that partly belongs to Y. So if I say only X, that's what I refer to there. Let's again look at our Venn diagram with 2 events. Take our same Venn diagram, same sample space, and an X and a Y. We'll look at different regions of the Venn diagram. Now, previously we looked at only X and only Y. Let's look at a new concept here. We say not X. Not X we can also write as X prime there, or we can say the complement of X. You see that little symbol there? We refer to that as X, the complement of X, which you can also write as not X. So if I say not the X, in other words, I mean not the A and the B. So if I take not the A and the B, it means I don't want it. See, the A and the B is gone. What am I left with? I'm left with C and D, right? So this region here, that is the complement of X. Can you see there? The X is the black, so the complement of the X is whatever is outside the X, whatever is not a X. Similarly, if I say not Y, take my Venn diagram back again. So if I want not Y, I also can write down complement of Y. So not Y means I don't want the B and the C. See, I remove the B and the C is now removed. So I'm only left with A and D. And if we now look at what would Y be, can you see there? Complement of the Y. Y is represented in black. The complement of Y is whatever is not black. That will be the clean portion that we have there. So now we have 2 new concepts, not X and not Y, which is complement of X and complement of Y. We use that little symbol for complement. 2 other regions we want to look at, so let's look at them now. Let's take our Venn diagram back again. Same sample space, same X and same Y. Okay. Remember previously we worked with only X, not X. Now let's look at this here. Now we want to combine the 2. Here I say X and Y, right? Now X and Y, I'm going to show you what we mean by X and Y. We also can write, instead of the and, we can use this symbol here for and, right? That's X intersection. I read that as X and Y, intersection of X and Y, right? And the intersection is, as it says, intersection is where the 2 circles intersect. In other words, where they overlap. So there's the intersection. What does this intersection consist of? That's right, B is the intersection. So intersection there, that's how we represent intersection. So this yellow portion here represents my intersection. Now let's look at another concept. Now instead of an and, we have X or Y. What do we mean by X or Y? We also have a symbol for or, and we use that union symbol. X union Y or X or Y. So you can read that as X union Y or X or Y. Now what do we mean by the or? The or is everything. It's both circles, but I don't repeat. So it's A, B, C, right? I don't write the B down twice. I just have A, B, C. So that is the union. So union there, this region here, right? It's the X together with the Y, but you don't repeat the element. See that overlap? We don't write it down again there. So that is the and that is the or. Now let's look at another example to show you how to draw a Venn diagram. Let's take the example of tossing a fair six-sided die. As you can see there you have a die with 6 sides and we're tossing it. So first of all, what would the sample space be? As we know, sample space would be 1, 2, 3, 4, 5, and 6. Now let's look at some events. Let's look at the event of getting an even number. So what would the even numbers be from tossing a fair six-sided die? That's right, it will be a 2, a 4, and a 6. Let's look at the second event. Getting a prime number. What are the prime numbers here? Prime numbers are 2, 3, and 5. Now what do we notice there? Yes, there's an overlap of 2 because 2 is even as well as prime. So if we represent this here, we'll have event A and event B, but they will overlap, right? And that overlap would be the number 2, the even number 2, which is both even as well as prime. Okay, and then we can write in the remaining elements of event A, which is the 4 and the 6, and then the remaining elements of the B would be the 3 and the 5. But don't forget, the sample space consisted of 6 numbers. What is the 6th number? That's right, we mustn't forget that 1. Now let's do some probability calculations. I want to determine the probability of A and B. What's the A and B? That's right, that's the A and the B. How many elements are there? There's only one number that fits in there. So the probability would be 1. Sample size is 6, so it's 1 over 6. Let's look at A or B, and A or B. I now notice there's the A or the B. So it consists of how many numbers? 5. So the probability there would be 5 over 6. Now we're going to consider an example where we're going to illustrate the events in sample space, and we're going to use a Venn diagram to do that. Let's take the example of tossing a fair six-sided die, and there you can see a die tossing there. What is the sample space? 1, 2, 3, 4, 5, and 6, right? Then consider the event of getting an even number. So what would the outcomes be here? The outcomes would be, that's correct, a 2, a 4, and a 6. Those are the even numbers I can get tossing a fair die. And event number B is getting a prime number. What's a prime number? The prime numbers we can get here is 2, 3, and 5. But what do you notice about those outcomes of those two events? That's correct, we've got a common outcome of 2. So if we represent A with that circle, that magenta circle, and we represent the B with this aqua blue, so the common 2 would be where they overlap, and that's where the outcome 2 would fit in there. Then we can complete the rest of event A. You can put the outcomes there. That's still missing is 4 and 6, and the outcome there for B would be 3 and 5. But the sample space consisted of 6 there. So there's one more. That's correct. One more. That's the one that needs to go there. Now let's consider the probability of getting an A and B. What do we mean by A and B? That means the probability of getting an even number that's prime, right? So which of these even numbers are prime? That's correct. That's the common one. What color is that? That's the green color. That's the AND part. So this is the AND part of the two circles that I have there for my Venn diagram. And that represents the AND there. So there's only one outcome, so it's 1 over 6. That's only the 2, so that's 1 over 6. Now we also want to consider A or B. So what does that mean? It is getting an even number or a prime number. So it can be there, it can be the even numbers, or it can be a prime number. So it's all of, that's correct, it's all of these numbers here. Outcome can be 4, a 6, a 2, a 3, or a 5. And how many are there? There are 5, so the probability there is 5 over 6. Now let's try to understand our Venn diagram. right? There we have the Venn diagram, and we have the number of outcomes is represented by E, A, X, D, H, B, and K, and M. And those are E, that's A, the region A, so that's that A part. H would be that part there. Okay, so if I look at C, I will see C consists of the E, A, the X, and the B. If I look at F, F consists of the K, the D, the X, and the B. Same way, V consists of the A, the X, the D, and the H. Now, if we say only C, right? So if I take only C, if I look at C, right? There's C. Only C. You know, C consists of the E, the A, the B, and the X. But B is not only C. B is part of F. X is part of F as well as V. And A is part of A. So I have to remove those parts. I remove the parts from V, and I remove the parts from F. So that region that's highlighted there, that is the only C, and that one consists only of E, so that one will be E. Now if I take the next one, only V, so if I look at V, and you see there are parts that are not only V, that's the A, the X, and the D belongs to others as well, belongs to chicken and fish, so I have to remove the fish part, and I remove the chicken part. And that leaves me with the only V. In this case, it's represented by the region H. So only V is H. Similarly, if I want only F, then only F here would be, there's the F, but I see F there consists of the B, the X, the D, and the K. But B, X, and D it's not only F, it belongs to others as well. So I have to remove this chicken part, and I have to remove the vegetable part. So the only F is then represented by that region K. So only F is K. Now let's go back to our three events again. Here we want the concept of not C, right? Or as we say there, the complement of C, or C prime, the complement of C. So not C. So if I say not C, I don't want the elements of C, right? In other words, that's what I don't want. And what is left there? So I don't want that, so I must take the C away. And what is left now? You see what is left? That's correct. There are 4 there. That is equal to the M plus the K plus the D plus the H there. Remember, this stands for the number of outcomes there. So it's M outcomes, K outcomes, D outcomes, and H outcomes. So I find the sum there. Let's go back again. If I want not V, so that means it's not the V, so I don't want those elements, so take those elements away, and now you can just write down what is left. So not V would be those 4 parts there. It's going to be the E, the B, the K, and the M, and we find the sum, so that gives us the sum M plus E plus B plus K. Similarly, if we say not F, so I don't want the F, so I must remove the F. I don't want the F, right? So what is left there? M, E, A, and H. So that is M plus E plus A plus H. And now if we say not C or V or F, right? Not C or V or F, so I want not the C, right? And the V or the F, so I don't want those elements. And what is the only thing that's left? That's correct, it's only M that is left there. Okay, so that answer there would be, see, it's only the M that's left, so not C or V or F, that is equal to the M there. Let's go a little bit further now. Now we want to have the AND, C and V, right? Before we show that to you, can you see the AND part? C and V. Right? That is the C, that is the C and the V, the A and the X part. That's the only AND, that's the AND part there. So the AND part there would be X plus A. Okay, let's bring everything back again. So now I want V and F. Can you see the V and the F? There's V and F. So what would be the AND, or the intersection? That's the intersection, that portion that's highlighted there in white, and that's the X plus the D. Similarly, if I want C and F, right? Can you see the C and the F? That's correct. That is the C and the F part. So it's that part there, which is the X plus the B. So that's the X. And now if we want C and F and V, right? All three of them, right? The intersection of all of them, that's that portion there. That belongs to all three of them. And that is only the X there. Let's take our diagram back again there. Three events. Now we want OR, C or V, or C union V. C or V, so I want the C or the V. So that is the C or the V. Can you see? That's the C or the V. Okay. And it's those 6 parts there. We have there's the C or the V. So that's going to be E plus A plus X plus B plus H plus D. Okay, let's bring everything back again. C or F, you try this now. Can you see that? That's correct. That's the C or the F, right? Isn't it? Right? And that there would be those 6 parts. There's the C or the F. And that will be E plus A plus X plus B plus K plus D. Now V or F, let's see where's V or F. V or F would be those two there. So those are those 6 parts. There's the V or the F. And it's K plus B plus X plus D plus H plus A. And now C or V or F, what does that represent? Give you a chance. That's what it is, right? But it has to take the M out. The M is not part of it. So it's those 7 there. So it's going to be E plus A plus B plus X plus D plus H plus K. Now let's do an example on a Venn diagram with 3 events, right? Here we have a case with 103 learners, and it's their food preferences here. That's chicken, vegetables, and fish. And here we have some information about that. So the first question there would be, we'd like to represent that in a Venn diagram. Then we have to calculate the missing value, and then there are some probability questions there. We're going to do each one separately. So let's go to the next slide. Draw a Venn diagram to represent the information. So that is what I need. So I just have my blank Venn diagram there. C stands for chicken, V for vegetables, and F for fish. Okay, let's see what's the first information that's given. 103 learners, food preferences. What's that 103? That is the total number of outcomes in the sample space, 103, right? So I put the 103 next to the X. Then next we say that 2 eat only chicken. Can you see the only chicken part? That's correct. That part there, that's the only chicken, right? So this part here, that's the only chicken. Then the next one here, we want 3 eat only fish. Where's only fish? That portion there is only fish. So I can insert the 3 there. Then the next one, 5 eat only vegetables. Only vegetables, so the 5 would go there. Right, so that's that one. The next part there, 2 do not eat chicken, fish, and or vegetables. You know where that is? They don't eat chicken, fish, or vegetables, and you just have to put it outside. There's the 2. Now let's see the next one here. 21 don't eat fish, right? So if they don't eat fish, in other words, it's not these people. So it's this one, and this one. So it's 2, this part, and this part here. Okay, so all together that should be 21. So I can find the missing part there. And how do we do that? That's because that's the part we want, right? So it's 21 minus 2 minus 5 minus 2, and that gives us a 12, right? So 21 don't eat fish helps us to get that particular portion here. Now next they say X is the number who eat chicken, fish, and vegetables. Where's the and part? Chicken, fish, and vegetables. That's correct. That's the part right in the middle. That's the X. Okay. Then next 75 learners eat vegetables and fish. Where's vegetables and fish? There's vegetables and there's fish. So this whole portion here, that should be 75. Not 75 here, but 75 between them. So to get this part here, it is 75. That's correct. 75 minus X. Okay. Similarly, 66 eat chicken and fish. There's chicken and there's fish. So the 66 is here. There's the 66. The 66 is there. So this portion here where the pointer is, that is 66 minus x. Okay, so there we've represented all the sections there. Now the next question is, now we want to calculate that value of this x here. Okay, now what do we know there? The sample space consists of 103, right? So the size of the sample space there is 103. So all of this together should be 103. So 2 plus 12 plus 5 plus 6 minus x plus 75 minus x plus 3 plus 2 should be equal to 103. So I set up that equation there, and this should be quite an easy linear equation to solve. And solving that, we end up with x equal to 62. So this is 62, and once we have that, we can say 66 minus 62 and 75 minus 62. That will make it possible. Now let's look at the probability questions here, and it's important that we read the questions carefully. We have to determine the probability of eating only chicken and fish. So if I look at chicken and fish, that's the chicken and fish, right? So that's the 4 and the 62. But they say no vegetables, so I must take the vegetable part away. So that only leaves us with that 4. So only chicken and fish, but no vegetables. That is 4 over 103. Next question. Probability of eating any 2 of the food choices. Any 2. So it must be 2 of the food choices. If I am there, I only have 1 choice. Here I have 2 choices. There I have, because that is chicken, and there's another 2 choices, and there's another 2 choices, right? So it's the 4 and the 12 and the 13, right? Only 2. I cannot use this here because that's 3 food choices. I said eat any 2 of the food choices. So any 2 of the food choices is 4 plus 12 plus 13. So that's the 4 plus the 12 plus 13, and everything we divide by 103. So that gives us a total of 29 over 103. Now let's look at the third question here. Determine the probability of eating chicken or fish. Chicken or fish. Chicken or fish would be that there. Those are those 6, the 2, the 12, the 4, the 62, the 13, and the 3. And we find the sum of that. So chicken is 2 plus 4 plus 12 plus 62 plus 13 plus 3. Get that total is going to be 96. And then the last one, probability of not eating fish and not eating vegetables. So be careful there. Not eating fish. So in other words, we exclude these people here. Okay. And not eating vegetables, we exclude that there. So we've excluded this and we excluded that. So we only left with the 2 and the 2. So that answer is 2 plus 2 over 103. So that's 4 over 103, right? If we had a question here, the probability of not eating fish and vegetables, right? So if I say fish and vegetables would be these people here. Okay? That would be fish and vegetables. And not eating that would be the others that I would have there. 5, the 12, the 2, the 4, the 3, and the 2. Now let's come to the most important part here, and this is the exercise worksheet for you now to practice. I've taken questions from previous external question papers and I've referenced them. Some of the questions I've slightly adapted. Here's a question on a Venn diagram. In this case, there are 2 events. Here's another one here. I also have one with 2 events, soccer and rugby. And then I've got another example here. And here I've got 3 events, events A, B, and C. The solutions you'll find at the end of this video. Here are the solutions to the 3 problems in the exercise worksheet. First one here, there is question 1. You can pause if you need to try it on your own first. Then here's question 2. Also, you can try it first and then pause, and then you can verify your answers. And lastly, here's question 3. Also, you may pause and then try to do the questions on your own. I do hope you enjoyed it. If you have not subscribed to my channel yet, please subscribe to Maths with Armin. I do hope that you have enjoyed this video on Venn diagrams and how to use Venn diagrams to determine probabilities. I also prepared many other videos on probability and on mathematics topics. Don't forget, please subscribe. Thank you.